Hello, I'm Brian Pardo, professor at Northwestern University and head of the Interactive Audio Lab. Today I'm here to talk to you about VoiceAssist, a program that helps people make better voice recordings. This work was done primarily by my graduate student, Prem Seetharaman, and we worked in collaboration with Gautam Mysore, Paris Smaragdis, and Celso Gomez of Adobe. So here's what we want to sound like when we make voiceovers, podcasts, those kind of audio recordings.
So in 1853, during the California gold rush, a leafleteer out west published the 10 Commandments for gold miners who'd come out to prospect.
All too often, however, it's more like this.
Unfortunately, our recordings usually sound like this, with too much background noise and reverb.
Now, the issue is, for a lot of experienced users, they can hear it, and if they can hear it, they can fix it. But for a lot of inexperienced users, they don't realize the difference between what they're recording and what someone like Ira Glass, that first recording, sounds like. So, what if someone can't tell the difference when they record? How can we help them? Well, when people can't tell if they're speaking too softly or too loudly into a microphone, they turn to a volume meter. And the volume meter has been so useful and so successful that this very simple interface giving you this feedback, immediate visual feedback, is on practically every audio recording device. Well, VoiceAssist wants to bring this idea of the volume meter to other aspects of sound quality, specifically reverberation and background noise. Let's have a listen to VoiceAssist in action.
If a user moves away from a microphone and there's too much background noise, the quality indicators become red, indicating that the user should make adjustments to improve audio quality.
As you can see, it's a very simple interface. If your speech is too boomy or reverberant, or there's too much background noise, one of these rectangles turns red. If it's sounding good, they stay green. And this kind of easy to follow visual feedback is really helpful when you're, say, reading a script or following visual cues. You don't have to focus your eyes on it. You can catch it in the corner of your eye and adjust. So how do we do this? Well, for room acoustics, the boominess, the reverberance, we measure the speech transmission index, which is a well-known measure of speech intelligibility. Now, the catch is normally to measure the speech transmission index, you have to get the transfer function of the room you're in. And this means recording sine sweeps or various things. It's an involved process, and generally we can't expect an end user, especially a novice, to do this for every room that they're going to record in. Instead of doing that, we train a machine learning device to learn the speech transmission index for different qualities of voice in various kinds of reverberant situations. We take something of high quality audio, for example, that Ira Glass recording we heard earlier.
So in 1853, during the California gold rush, a leafleteer out west published the 10 Commandments for gold miners who'd come out to prospect.
And this has a speech transmission index of 0.95 on a scale of 0 to 1. And then we apply room reverberation, where we know what it'll do to the speech transmission index, and get something that is lower quality from the perspective of doing a good audiobook, for example.
So in 1853, during the California gold rush, a leafleteer out west published the 10 Commandments for gold miners who'd come out to prospect.
And we can do this over and over with many different reverberations on many different audio recordings to make lots of examples that we use to train a deep net. And the deep net is fed a second of audio. It outputs its estimate of the speech transmission index. We compare that to the true speech transmission index of our data set and use that as a training feedback loop. After thousands of iterations, the model gets really good and gets a very good estimate of the speech transmission index for voice recordings under all sorts of circumstances without having to measure the room. For background noise, it's simplicity itself. We just detect when speech is occurring versus not, and get the ratio, the RMS amplitudes, the root mean squared amplitudes between the no speech and the speech conditions. And we map that onto color. So does VoiceAssist really help? Well, we ran a study. We brought people into the lab and asked them to read some text aloud like they were reading for an audio book and record that. The only visual feedback they got was a volume meter.
The appearance of the island when I came on deck next morning was altogether changed.
Then they were asked to listen to their recording and adjust the microphone, levels, position, anything they wanted to make a better second recording. And here's the second recording for this person.
The appearance of the island when I came on deck next morning was altogether changed.
Now, I don't know about you, but I didn't hear much of a difference. Let's back up and hear the first and second recordings again.
The appearance of the island when I came on deck next morning was altogether changed. The appearance of the island when I came on deck next morning was altogether changed.
Okay, now let's listen to a trial that we did where someone first did the recording just like in this example, with just a volume meter as visual feedback.
The appearance of the island when I came on deck next morning was altogether changed.
But then was shown voice assist, given the opportunity to listen to their first recording, play with voice assist, and then make a second recording. And here's the second recording with voice assist.
The appearance of the island when I came back on deck the next morning was altogether changed.
I think that was a much bigger difference. Let's have a listen again. Here's the first one.
The appearance of the island when I came on deck next morning was altogether changed.
And here's where they had access to voice assist.
The appearance of the island when I came back on deck the next morning was altogether changed.
Now, these are not cherry-picked examples. These are typical examples. And we actually ran a third-party listening study to see which ones they preferred. So in the control condition, where both the first and the second recordings were done with just a volume meter, third-party listeners were equally likely to prefer the second or the first recording. But when the second recording was made with voice assist, there was a 3-to-1 preference for the voice assist recording. Now, interestingly, we also had the people who made the recordings rate their own recordings, asking which one they preferred, first or second. And self-reported quality was no different between the first and the second recording, regardless of whether voice assist was used. And this tells us that neophytes, such as the ones we recruited for our study, really often can't tell the difference between a higher and a lower quality audio recording. So what this tells us is voice assist helps, even or especially if the user can't tell the difference. Okay, so that's voice assist. For more on this or other things that we do in the Interactive Audio Lab, please check out our website, interactiveaudiolab.github.io. Thanks for your time.